Hello guys and welcome to a new Houdini beginners tutorial. First of all, I just want to give you a quick information. I'm on Instagram via TIMJ design. I post there small R&D stuff and my bigger projects, and Instagram stories are currently full of my own tea, nice, and stuff like that. So I post there my current projects, R&D processes and so on. And I'm also on Behance, where I publish my big projects. Cool. I scaled up the Houdini interface a little bit so you can follow me better along. In this series today I want to talk a little bit about simulations in Houdini, and I think the first simulations that should everyone start with are pops, because I think particle simulations are pretty easy to handle and to art direct, and we will do that today a little bit. First of all, press tab on your keyboard and you will get your node window here, and press or type geometry and place down a geometry container. We will rename this to geo pop and give it a black color and a round shape. Let me just save this quickly to the desktop. Cool. Then we will dive inside. We can dive inside with double click or the I key, and with the U key you can dive up one level. So now we are in the geometry container. But we don't got any particles. We want to start first with a pop network. So a particle network is placed, it's called popnet, and we want to rename this particle particle 001 for now. When we play here, nothing will happen, because when we dive inside we will get overwhelmed first of all by a few nodes, but these are all pretty simple. This is the pop objects. Here will the particles will stored in here. So you, for example, you can get into the mask here and you only want to export, for example, the pop object, then only the particles will be visible or will get exported out of the simulation container. This is the pop source. Here are the particles generated. Then here is a merge node. So you can wire forces into here, and you can also wire forces into the pre-solve. Then this is the solver. Here you got sub-steps. You got the time scale, so if you want like slow motion, you can set this, for example, to 0.1. The sub-steps, then the updating, for example, use mass, H particles, then the collision behavior, sleeping, bindings, and distribution. But I think for the start it's just important to know the time scale and maybe the collision behavior. We will dive up one level and go to the simulation tab. Here you can change the parameters again, the start frame and the scale time, for example for fast forward or slow motion. Substeps are important to divide every frame into smaller steps to get a more accurate simulation. Then the time step, this will be linked with the substep. So higher the substep, the smaller the time step will be. Here you can reset your simulation, and I think that's everything to get started. Now to the pop source. We will not use the pop source for now, we will use the pop location. So press tab and type pop and then L, and then the second one is the pop location. We will wire that into our merge node here, and you can see immediately some particles. So let me get them a little bit bigger here. You can see immediately particles, and when you press the simulation key or the forward key or the up arrow on your keyboard, you can already see we've got some particles. They will go in every spherical direction, and when you press the real-time toggle you can see it in real time. So I will make them a little bit smaller again, and yeah, that's it. We will get this spherical distribution because of the variance of the velocity. When we, for example, make them a little bit smaller, so this is the x direction here, and we will make that smaller, we will get something like this. So already with 0.1. Already with a simple change of just 2 parameters from the velocity, you will get something like this. Cool, but I will disable them completely for now. So variance 0, 0 and 0 in the velocity. Where we now reset the simulation and start again, nothing will happen. They will always be in the center point 0, 0, 0. But I want some movement. But first of all, I don't want to make a continuous birth. I want to make a impulse birth. So what we want to do, we will dial down the constant birth rate to 0 and the constant activation to 0. I think they should change this to a toggle maybe. And the impulse activation, we will go there with a little expression, and let's go to frame 1, and we will say $frame, the current frame, equals 1. So if the current frame equals 1, we will emit particles. And then the impulse count, how many? You can say 1 particle or 5,000. So I will stick to 250 for now, and you can see on the first frame we will get 250 particles. But we will see no movement. So let's get a little bit of movement in here. Let's get a simple pop attract node. This will attract particles to a given location. And the goal, I want the goal at, let's go 1 up. And we will use the accelerate function here for scale 1. I think that's fine. And now you can see every particle will travel up, and when the timeline here is long enough, they will eventually be in the goal position 0, 1, 0. So that's some moving particles here, but nothing special. The pop attract is pretty cool, but we will use that. So we will use that, but we want a pop wind. And the pop wind will split things up a little bit. So just like that, and then we will use a little bit of variance here. So 0.25, 0.25 and 0.25 to split them a little bit up. And now you already can see we'll get a really cool motion here, and because we've got our goal here, the particle or the particles are trying to reach this goal position over time. We can increase the force scale here to, for example, 5 to get there much faster, and you can see the force is much stronger now. But you can already also try out the follow. But I think for the follow you need a little bit more force. Okay, let's go back to that one here. 2.5, and you can already get some pretty interesting results. Let's go to make the amplitude a little bit bigger and the swirl size. So you can dial it down, for example. You will get a little bit more random distribution. When you dial it up, like 2, you will get a much smoother distribution. And the cool thing is you can already use that to create something. I like to make R&D with the trail node, because the trail node will connect the points to a line, and you will place down the trail node, connect as polygons, and toggle the close rows here. And now you can see we will already get something like this. And I think that's already pretty cool. To visualize that a little bit better, you can place down a resample node, bind out the curve U attribute and visualize the curve U attribute. Curve U, where is it? Here. Cool. What we can do now, we can go back to our source first input, and this will source onto a given geometry. When we place down a grid, for example, it will scatter on a grid here, and we will get something like this. Every particle is currently following the goal and will get affected by wind, but I think the grid is a little bit too big, so let's make it a little bit smaller here. Another thing, let's get another grid, let's place down a circle, and in that direction or orientation, polygon, increase the size. You don't need to make it a polygon, but. And I think the goal is a little bit too low here, so we can increase the goal by going back in our solver to the pop attract, or you can rename it PT goal, something like that. And we will make 2.5, or let's go a little bit higher. And you can already see we'll get pretty cool movement here. And they will try to reach the goal here. It looks like, yeah, like a flame a little bit. The cool thing is we'll get different parameters here, and we can say we want to let the particles die after a given duration. We will go to our pop source, to our birth, and here is life expectancy. The life expectancy is in seconds, so keep that in mind. when I have 24 frames per second, after 24 frames the first particle or the particles will die. So you will get something like this. Another cool thing is you can play with the live variance. This is also in seconds. Let's go a little bit higher. So for example 3 seconds life expectancy, but I want a variance between 0.25 seconds, and then they will reach the goal, or let's make it a little bit longer, like 4 seconds. They will reach the goal and then die. So you can make something like this. And of course now that's not a lot of particles, that's just a bunch of particles. You can go much higher here. For example 50,000 constant birth rate. And now the cool thing is we will dive up here for a second and visualize the age parameter. And you can see the youngest particle or the oldest particles are red, and yeah, it's basically like a ramp for each individual particle. So they will birth and then they will get older and older and older and then die. And the cool thing is you can use the age in rendering. We will do that also, but I want to get a little bit of spin in here, and I really like this force. Also I like this force really for Vellum, because you can do a lot of cool stuff with the pop axis force. I want to disable the goal for now and the wind, and just let the pop axis force do its stuff. And you can already see the particles will turn and then spin out because of the outwards force that will get generated. You can change the scale here. So I will go for 1 and 2.5 in the height. You can change the orbit speed, so to get a much stronger orbit speed you can go with 5 for example. Or the suction speed, you can suck it in here. And that's also pretty cool. You can make like portal, stuff like that. And for example, when we activate our goal here, so this is because of substeps, so you can get away with that with substeps, but we will get something like this. I think that's pretty cool. So let's dive up for a second and just increase the substeps here a little bit, and you can see we will get a much better resolution, but I think 5 will be enough, yeah. And we will get something like this. Let's go back with the substeps to get a little bit faster representation of our particle simulation. Now we enabled the goal, let's also enable the wind. And we will get like a particle tornado. I think that's really cool. So with the pop axis force you can do a lot of things. The tornado form is currently because the form will happen because of the suction speed. So when I disable the suction speed, you will get something like this. And for sure you can animate, for example, the suction speed over time. Or let me just get the lift speed to minus. I think that's also pretty cool. But let's go back and enable the suction speed again. Of course you can play there with pretty high values, you can do that and get a really cool swirly look here. But I think 5 or yeah, maybe 3.5 should be enough to get like a good this kind of tornado form, but also secondary particles on the outside here. Let's get, where is the pop kill? Here. The pop kill is also, I think, an important node. When you got your pop kill here, you will enable the pop kill, and you will enable it by a bounding box. All particles in this bounding box will die, for example. So you can do that too if you got a pretty heavy simulation and you've got a camera, maybe like, let's just make a camera here, maybe something like that, and you've got your current framing here and the particles are pretty heavy, like several million, and the particles will rise and then you don't need them anymore. You can just go with the bounding box up here and you can kill the particles on top here to save memory. So pop kill is a pretty cool node. Keep that in mind. You can kill them random. You can kill them randomly with a 0.5 chance, for example, or you can kill them with a bounding box or with a rule in Vex. So that's the pop kill node. Another cool node is where is it? Yeah, the pop interact is pretty cool, but we will make that here. Collision behavior, add hit attributes and color hits, for example. And now what we can do, we can place a collision object. Let's move that to the second input and transform the sphere a little bit up. Let's get a good resolution on the sphere here and move the sphere a little bit upwards. Let's have a look. Okay, that should be fine. We'll dive inside here, place down a static object, place down a merge. Left affects right input, so switch the inputs with Shift R, and we need our sphere. We can just do it with a simple import here. Place down a null, call it out collider. Let's copy the null node, so Control C, Control V to paste it, and we've got our collision geometry. Let's have a look at the collision guide. I think that's okay for now. And now you can see it will color the hits. They will get red, and you can use that, for example, for rendering or all kinds of stuff. Another cool thing is what I said earlier. You can now only extract, for example, the pop object, so only the particles. Let's dive up one level, and we see the sphere here, but we don't want that. So you can just object merge object and then pop object, and you will only get the particles. And I think that's pretty cool, because you now get like a invisible collider relationship, and I think you can do a lot of cool stuff with that. Oh, we should increase the cache memory here a little bit. and I think that's pretty cool. When you want to extract it like a separate sub, you can do it like so. Place down .io import. Then we need a .dop network. Just drag and drop the .dop network in here, and then here the let me have a look at again the pop object here. Pop object, and nothing will happen because we need to fetch geometry from .dop network. And now you got only your polygons. So that's pretty cool too. I want no collision for now, and I think that's already pretty cool. Let me have a look at the time here. Okay, cool. Let's increase the particles a little bit. And I want to increase, let's increase it further, and I want to increase a little bit the given time to the particle, so 4.5 seconds. What we can do now, we can have a look with the trail, so let's increase that a little bit because that's pretty heavy. Let's simulate that a little bit. And you can use that also with the trail and the resample. But I think that was a little bit heavy. But let's have a look. Resample is going and going and going. Yeah, you will get something like this. So yeah, let's let's increase it, decrease it a little bit here. So like 1,000 for now. The problem is here with a single activation, the trail and the resample is pretty fast, but yeah, with something like that, it's pretty bullshit. So what you can do, you can just copy and paste it here. You can go back to our impulse activation, so for example 2500. Now you can go much higher because there is no resample and trail issue with the point ID number. $FF equals 1, so we will just spit out one amount here, and they will die up here, and now you can see that's much better, and you will get really cool results here. Don't let them die, so yeah, I think that's pretty cool. Cool, but these are now trails, so trail combined with dops or pops, really cool, but we want to stick with particles for now. Yeah, that's of course the one here. We'll go higher. I think that's cool. Let's increase our sub-step here a little bit. So 3 sub-steps. And let them cache a little bit. The cool thing is what you can do, for example, for still frames, you can cache the still frame out or the whole simulation, and then pick one frame you like and play with that. These are just points, and I think that's a cool thing because you can manipulate them further with a point warp or vex or something like that. I think that looks pretty cool, especially maybe with close up. Nice. Let's place down a null here, and I want to cache them out, so file cache. Let's just cache them out a little bit, so frame delete channels, frame 69, cache them out quickly. Or it's on my other screen. And I want a file, so you can stay a little bit better organized. Right click on the geometry file, copy parameter, select the file node, right click and paste relative reference. And now you got a cached out simulation here. Cool. What I want to do now, let's set this up for rendering with Redshift. I will just adjust the camera here a little bit, adjust the focal length, the resolution, depth of field a little bit. When you are in Redshift, I think I do this every tutorial, but again, copy the parameter from the focus distance, paste it into the focus distance from the Redshift. Let's stick for now with 0.1 and get a bokeh image here. Select the camera, let's move a little bit in here. Get the focus back. And I want a light, RS light dome. I will select the dome map. Let's stick with that one. And then I want a material network and a ROP network. So material for materials and ROPNet for rendering, RS outs and RS mat. Select both, color them in if you want to do that. Camera is already selected. We can use global illumination, and I will also use automatic sampling and optics RT for RTX cards. Dive inside the RS mats and place down an RS material builder. Let's call this RS mats PTS for particles. And we are ready to render. But first of all, I want to have a look at our geometry spreadsheet and on the edge. And I want to fit the edge, so place down a min-max node. You can download the min-max node for free on my Gumroad. And we will fit the edge here. And now you can delete every attribute you don't need. So attribute delete. And I will delete, 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 and delete. But I don't want to delete the edge attribute here. That's a wrong A. So now we've got just our group, our position of the points or the particles, and our edge attribute. And the edge attribute is now fitted between 0 and 1. And I think we are ready to render. Oh, one more thing. We need to assign our material, so just copy the material and paste it in, or go here, choose operator here and select the material. Then we need to go to Redshift object parameters and go to the particles and render object X particles. Let's go with 0.1 global scale multiplier and let's have a look. Let's start the render here. And we will get particles. Cool. Let's disable the background for now, and I can already see I think they're a little bit too big. So I will go a little bit smaller with the scale. And I want a cool camera angle, something like that. And I want to pull the focus a little bit back because I think, yeah, way out of focus here. The COC radius is way too high. Yeah, that's better. Let's make it a little bit brighter. Expose on 1. And dive inside the RS material. And now we can play, for example, with a ramp and our H attribute plays down RS user data color, H, that into the ramp and that into our color here. Okay, I think there is H. That should work. Let's just point at root H and it's fitted, okay. Let's view it like that here. Okay, I think it's, yeah, okay. Yeah, it's working. It was just this little framing issue because I didn't saw the whole ramp. But now you can pipe that into the diffuse. Let me try to get okay, the resolution is fine. And now we can play. Let me grab the focus here. Yeah, okay, cool. Yeah, and now you can play with your first little particle simulation. It looks like a smoke. Oh, I really like that one. Sure, complementary colors are also nice. Let me grab the focus back here. And I think we can scale them a little bit up. To get something like this. And now of course this is just really basic. You can play with the materials. Go with copper. Copper is cool. Oh, that's big. Okay. It wasn't on the full resolution. Yeah, now it's much better. Yeah. Now you can see the particles. You can what you also can do, you can get a little bit of motion blur in here. Don't delete the velocity. It's also on the points, so V, go to RS, output, no, Redshift, motion blur, enable instances particle blur, and now you can already see your motion blur here. 0.25. Yeah, and you can see a little bit your motion blur. And of course you can adjust it, make it stronger, make it less stronger. But I think that already looks pretty cool in my opinion. What you can do now, of course, play with the camera, play heavily with the simulation, with the parameters, the forces and so on. And for example, with the camera direction, focus, aspect ratio and so on. Just get that in the reflectivity. And yeah, I think that's it for our first little particle trip. And I will see you in the next video with Beginner Series Part 3. Have a nice day and stay safe.